Okay, we're on the screen recording now. All right, and let me go to the slide here. And this shows you the damage that can be done. Players that undergo that 98 Gs of acceleration, for comparison, they drive into a wall, and it's the impact is huge. And then contra-coup action causing back of brain to impact posterior aspect of the call. In other words, when you hit, you get thrown back and then thrown forward. That's why you see people, and subsequent contra-coup injury to front and back of the brain. So you get a thing to the back of the brain, impact in front of the brain, and eventually it starts to um, break down the brain. All right, so the world's, and you wind up with getting what is known as CTE, which is what I think my father, who passed away about a year ago, had, because he displayed manifested all the outward symptoms of dementia, and he had it, and he couldn't speak really in later on in his years. And he was a really bright guy and funny guy and a marathon runner up until, in fact, on his 77th birthday, his dementia was starting to get a little bit too dicey. But he always had a goal that every time he ran a 10K, the number of minutes would equal to do the 10K, he would do it in that amount of time, in those many minutes compared to his age. So, like, I'm 57. If I ran a 10K following his thing, I'd have to run it within 57 minutes. I'm almost there. Where I'm averaging about a 10-minute mile now for a 10K. But I need to lose about 30 pounds, and I think I will be there. But I like beer. Anyway, and I like red meat, damn it. But anyway, he was in a really, really bad motorcycle accident without a helmet back in the 50s. And I really think that's what caught up with him. But because he acted a lot like John Mackey did in that video that you saw. Anyway, let's get on to happier stuff, shall we? Why not? So the world's fastest legal street. Okay, so here we go. How does the acceleration compare to the acceleration due to gravity? What force can be seen on this thing? So here we are. It goes from 0 to 60 in 2.78 seconds. Of course, we have to convert that to meters per second. Convert everything to metric. Multiply by 0.447. We get the 26.8 meters per second. Calculate, subtract the final minus the initial, divide by the time. And we get 9 point. It's almost a G. By the way, interesting point. World-class sprinters like Usain Bolt and that field of sprinters that he was with at the Olympics, they also accelerate for a very short amount of time. They can't maintain that acceleration for 2.78 seconds. Otherwise, they would be going 60 miles an hour when they got to... And in fact, I don't know how fast they'd run the 100-yard dash if they could get going, because actually they accelerate very rapidly and then deaccelerate. And it's the ones who can control their deacceleration the most are the ones who win at the end. But anyway, so it's really close. F equals ma, 12,000 force, so 12,000 newtons. Okay. Now momentum, the most important thing. One of the most important things in physics. The quantity, it's just mass times velocity, appears so often that we give it its own name. It's called momentum. P equals mv. Okay. That's your equation for momentum. That shows up on your homework. All right, momentum. Remember, F equals ma. If F equals 0, then ma equals 0. If there's no acceleration, then the velocity is constant. If the velocity is constant and mass does not change, P equals mv is a constant. So if all the external forces add up to be 0, and I've got this. So go ahead and watch the next couple Newton's cradle things, and you'll see these collisions. And that's the conservation of momentum, because the force of gravity, and it's also an exchange of energy. What you're going to see is an exchange of energy from one to the other in Newton's cradle. And the conservation of momentum, so all those, conservation of energy, momentum, but you'll see that the Mythbusters have a little bit of problem when they try and use some wrecking ball. So go ahead and watch the two Mythbusters. There's a Mythbusters video and this video for the conservation of momentum. And I'll stop here. stop here.